so we can see this example, yeah. This example 5.1. This example 5.1, yeah, it taken from the book Electrical Machinery Fundamentals, author Stephen J. Chapman, fifth edition. Okay, we can see a 208 volt, 45 horsepower, 0.8 power factor leading, delta connected, 60 Hz synchronous machine has a synchronous reactance of 2.5 ohms and a negligible armature resistance. Its friction and windage losses are 1.5 kilowatt and its core losses are 1 kilowatt. Initially, the sub is supplying a 15 horsepower load and the motor's power factor is 0.8 leading. Okay, so yeah, from here we understand that the three-phase synchronous motor has connection of delta. This one, yeah, delta. Now, so because it is delta, the voltage of 208 volt here, yeah, is the phase voltage is equal to the line to line voltage, yeah? Because delta, for delta connection, phase voltage equals line to line voltage. And here 45 horsepower, meaning it is based on the data sheet, meaning the maximum motor load is 45 horsepower and 0.8 power leading. Yeah. And then the synchronous, yeah, this one, yeah, phase voltage, yeah, I write here, phase voltage 208, yeah, angle 0 degree, because remember, phase voltage is always is as reference. Now, so the angle is 0 degree. And then power factor is 0.8. Yeah, it is almost same, yeah, when the loaded by 15 horsepower and also the maximum motor horsepower 0.8 also, yeah. And then has synchronous reactance 2.5 ohms, XS 2.5 ohms, yeah. And then a negligible armature resistance, RA is equal to J0, meaning RA is equal to 0 means it has no copper, yeah? copper power losses. There is no PCU, yeah, PCU that is equal to 3 multiply IA power 2 multiply RA is equal to J0, yeah. Its friction, yeah, its friction and windage losses are 1.5 kilowatt. Friction, yeah, friction and windage, meaning it is a type of the mechanical losses. Yeah, so mechanical losses is equal to 1.5 kilowatt. Its core losses, yeah, its core losses. Now, so 1.0 kilowatt, yeah, core losses 1.0 kilowatt. When initially the sub is supplying 15 horsepower, meaning this one is maximum power, yeah. It means the motor can supply for the mechanical load 45 horsepower. But when, yeah, meaning we want to analyze, we want to calculate the some parameters when the motor is loaded by 15 horsepower. And then remember, I repeat again, if it is given in the horsepower, meaning mechanical, yeah, output for the motor output. Now, so output power is 15 horsepower. Yeah, this one, yeah. Okay, the question, yeah, find the value of IL lines current, armature current, and internal generated voltage EA. After that, sketch the phasor diagram of this motor. Ya, ini pasal skate about the skate. Ya, please understand how to draw, how to sketch. Same in the test 3 also you have to sketch the phasor diagram, per piece phasor diagram. Can then be assumed that the sub load is increased to 13 horsepower. Sketch the behavior of the phasor diagram of response to the change. Yeah, now so we know the load is 15. After that, the load to be 30 horsepower. Now so mean there is the load change. You have from 15 to 30 horsepower. Now so you have to draw this condition also. You can draw in the one sketch ya. Timpakan saja dekat situ nanti. Okay. Now, so this example relate, we want to know the behavior of the synchronous motor when the motor has the load change. Okay. And C find IA, yeah, armature current, line current, and internal generated voltage after load change. What is the new motor power factor? Yeah. Now, related to power factor, you can see from the angle of the armature current, and then remember if the angle is has positive sign meaning leading, negative sign meaning lagging. Yeah. Okay. Now we want to find the line current, armature current, and internal generated voltage. After that, sketch the phasor diagram. Okay, now so because the output power is given for the initial motor condition 15 horsepower, this value can be converted to be electrical power, in watt. Now, so we know that the 1 horsepower is equal to 0.746 kilowatt. Now, so we can see here, initially the motor's output power is 15 horsepower. This correspondent to an output of output power. The output is equal to 15 horsepower multiply 0.746 kilowatt per horsepower. It is, I think every student knows that 1 horsepower is equal to 0.746 kilowatts. Now, so for 15 horsepower, we obtain 11.19 kilowatt. It is the output power. When we want to find the line current means line current that has for the input part, input part. Now, so this condition we have to find the input power lah. Because we know that for the total power, for the delta connection, we have to find the input power, or the power is equal to 3 multiply phase voltage multiply I phase multiply cos theta. Or if you want to find to use the set 3 for the total power, so PT is equal to set 3 line voltage multiply line current multiply cos theta. Now this one line current. Line current. Now so the first we have to find the input power. Input power. Remember the input power is equal to output power plus mechanical load, mechanical losses plus co-losses plus electrical losses. Electrical losses in here is copper losses. That is equal to 3 multiply IA power 2 multiply RA, and here is 0 because RA is negligible. The output power is obtained 11.19 kilowatt, and then mechanical losses 1.5 kilowatt is given, yeah, from here. And Colossus is also 1. Yeah, this one 1. And then electrical losses is 0. So the input power, yeah, for the condition motor is loaded by the 15 horsepower. Input power is equal to 13.69 kilowatt. Yeah, this one. Yeah. Now, so after obtaining the input power, we can obtain the line current. Yeah, line current, please use this formulation. Yeah, input power is equal to surge 3 multiply line voltage multiply line current multiply cos theta. Yeah, remember, because it is the delta connected, yeah, now so line voltage is equal to phase voltage is equal to terminal voltage. Nah, terminal voltage, phase voltage, line to line voltage is given from this question, yeah, 208 volt. So in here we can write IL is equal to input power over /3 terminal voltage multiply cos theta. And cos theta obtained also. Yeah, when the 15 horsepower 0.8. Leading, yeah. Leading means the angle is positive. And then current leads phase voltage, yeah. Armature current leads phase voltage by, yeah, how many degree lah if the cos theta 0.8. Yeah, yeah, yeah. Now so line current input power taken from here. Okay, 13,690 over /3 208 multiply cos theta 0.8. Now so we obtain 47.5 amperes. Yeah, this one is IL. Okay, obtain, yeah, line current. And then armature current. Yeah, we know that relationship between line current and armature current for the apa nama itu delta connected. Yeah, for the delta connected system, phase voltage equal terminal voltage equal line voltage. Yeah, but line currents is equal to /3 phase current, or line current is equal to /3 multiply armature current. Ya. Ya, ini kalau ini saya derive sendiri saja ini ya. Ini kalau nak guna ini punya boleh. Okay. Nah, so we want to find the armature current. Okay, this one ya. Okay. Nah, armature current is equal to line current over /3. Yeah, we want to write this IA in the phasor form. Now, so angle cosinus inversely 0.8. Yeah, this one. Now, IL is 47.5 over /3. We obtain 27.4. Yeah, cos inversely 0.8 is 36.87 degree. Now, so this one is value of armature current. Yeah, this one, yeah, armature current that it is written in the phasor form. Okay, and then we want to find the value of internal generated voltage, EA. Yeah, for this case, we know that the relationship between, yeah, phase voltage, remember for the synchronous motor, phase voltage is higher than internal generated voltage. Yeah? Now, so phase voltage is equal to EA plus JXSIA plus IAR RA. And here, remember, IA RA is equal to 0. Why? Because RA is negligible. Yeah. Okay. Now, so we can find the value of EA. Yeah. The first from this formulation, phase voltage is equal to EA plus JXSIA. Now, so we can write this value of EA is equal to phase voltage minus JXSIA. Phase voltage obtained from the question, yeah, from the question from here. From here, yeah, we write in the passive form. Okay, XS is here 2.5. Okay, now so we can write the value of EA, yeah, like this one, yeah. Phase voltage 200x, angle 0 degree, minus XS is 2.5, ya. Inilah saya urai ya, saya urai. J, this angle is 90 degree. Multiply IA from here, 27.4, angle 36.87 degree. Nah, so 2.5 multiplied 27.4 is equal to 68.5, ya. 90 plus 36.87, 126.87 degree. Yeah, now so if we the last value of internal generated voltage is 255 angle minus 12.4 degree volt. Yeah, look at here. This angle, this angle of the EA is negative. Now, so we can draw, we can sketch the phasor diagram. The first, you draw the phase voltage. Yeah, phase voltage. The phase voltage, you're following the 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 question is 200x angle 0 degree. Nah, ini terpulang ya. Nanti ya up to you. You can give your the scale follow each student lah ya. Yeah, for example, this one lah. Okay, it is the vector phase voltage 200x angle 0 degree. Dan nanti supaya ini dinyatakan this one is correct, ya please write ya the value and also angle ya. 200x angle 0 degree. After that, you can sketch, you can draw the internal generated voltage EA. Yeah, remember because in here, yeah, in here the angle is minus 12.4. Now, so it's around like this one lah. These are the angle, yeah. For the EA, 12.4 minus, yeah, because minus here, lagging. EA lag phase voltage by 12.4 degree. Yeah, this one. Okay, now so how many scale for you? Up to you. Okay, now so we can draw the EA like this one. Yeah. Now you can write lah the value 255 angle minus 12.4 degree volt. Yeah. And then after that you can just drag, yeah, just draw the one line. Yeah, one straight line from this end of EA to this end of phase voltage. Now this line is JXS, yeah, IA. Yeah, this value is 68.5 angle 126.8 volt. Yeah, this one, yeah. Okay. Okay, after that, if you want to write, if you want to draw the IA, yeah, IA from here, 27.4 angle 36.87. Yeah, this angle is 36.87. Okay, now so you can draw like this one, and then you can write the value, ya, this one, ya. Okay. Oke, pasal ini dulu, yang part A, boleh paham sampai dengan cara to draw the or to sketch the phasor diagram.
Paham betul.
Oke, alhamdulillah. Oke, thank you ya. Oke, kita lanjut ya. Oke, then NB pada soalan dia assume the sub load is increased to 30 horsepower. Sketch also. Oke ya, and then C lah, saya lanjutkan dulu direct C. Find IA, IL, NEA, and the last is new motor power factor ya. Oke, and then for the B, ya, ini saya tulis, ini pun saya ambil dari buku juga, ini cara tulisan dia. I taken from the book. As the power on the shaft is increased to 30 horsepower, the shaft slows momentarily. and the internal generated voltage EA swings out to a large angle delta while maintaining a constant magnitude. The resulting phasor diagram is shown in figure below. Nanti kita tengok ya phasor diagram dia. Mana I mean like this one. Remember, yeah, there is the two conditions. Yeah, when the motor is operated for the load change and the flux change. Remember, for this example, 5.1 is load change. When the load change, the motor is always remain in the constant internal generated voltage. Constant internal generated voltage. EA is constant. But this angle of delta, delta is angle created by the EA dan NV phase voltage will swing maknanya will take a new delta. Nah, so for the constant EA, how many delta? How many angle for the delta? Nah, inilah mau kita kena cari. We have to find. Nah, so when we want to draw this one, mananya yang ini nanti EA ini tetap 255. If the motor has the load change, horsepower dia change, tetap 250 volt, tapi dia angle dia berapa? So nanti kalaupun ada ataupun kalau tak, if you have the apa dia punya apa namanya? Tracing yang dia boleh gambarkan dia punya ini untuk gambar cycle, Nah, so ambillah daripada ini dia is as initial point dan ujung dia dekat sini. Yang untuk gambar cycle lah, macam itu ini Soal cycle macam ini, kan dia kalau cycle has the radius same mana-mana titik kan sama. Macam itulah. But is the angle is different. Starting from this reference phase voltage for the angle Okay. Now so we can see for the load change to be 30 horsepower. Same, the 30 horsepower in here is as the output power Now so we can find the output power for the 30 horsepower. This one. So 30 horsepower is multiply 0.746 kilowatt per horsepower. Now so the output power is equal to 22 point This one is 0.38 kilowatt. This one. Same. If the output power is 32.38 kilowatt, how many input power? The input power from this formulation. Input power is equal to output power plus mechanical losses plus core losses plus electrical losses. Output power is 22.38. Mechanical losses is 1.5 kilowatt and core losses 1 kilowatt. Now the total input power is 24.88 kilowatt. This one. 24.88 kilowatt. Okay, when the electrical supply to the motor, input power increase correct increase P in before 13 before 15 13.69 when the 30 horsepower to be 24 increase Now so the internal generated voltage of the synchronous motor remain constant. Remain 255 volt for the voltage for the internal generated voltage. Only this angle will change. Now so how to obtain it? Remember remember I repeat again synchronous generator, which one is it? Yeah, remember when yeah the armature resistance is negligible, Ra is equal to 0. Remember, the convert losses, power losses is equal to input power. Yeah, remember this one. Yeah. Now, so P input is equal to 3 phase voltage multiply EA over XS multiply sinus delta. Now, so means the value of delta can be found from this formulation, yeah? This one, yeah? Understand, yeah? Now, so we want to find the angle delta, yeah? Starting from this formulation, yeah? Now, so we can write, yeah, from here that input power obtained 204.88 kilowatt or to 24,880 watts. Yeah, here we can find this angle. Yeah, delta is equal to sinus inversely input power multiply XS over 3 phase voltage internal generated voltage. Yeah, this one, yeah. Now, so we substitute value of input power to 224,000, yeah, to 24,880 multiply XS tadi berapa? XS 2.5, ya, 2.5. Nah, this one, ya, multiply 2.5, ya, 2.5 over 3 phase voltage 208 multiply EA is equal, EA is 255. Now, so we obtain value of delta, yeah, is equal to 33 degree. Yeah, 33 degree. Yeah, and then remember, the 33 degree, it is the angle for the value of internal generated voltage. And the internal generated voltage is always lag. Yeah, is always lag phase voltage. Yeah. Now means this angle should be negative sign. Okay, now I write here. The internal generated voltage EA is given by, yeah, remember, yeah, CEA, yeah, is remain in the constant value. Yeah, remember, yeah, constant value before 255 remain 255, but the angle change. Yeah, change from minus 12.4 to be minus 33 degree. Okay, and so the value of EA when the motor has load change of 30 horsepower, so the internal generated to be 255 for the angle minus 33 to 23 degree volt, yeah, this one, yeah. Okay. Now, so from here, we want to find the value of IA. Yeah, IA. Yeah, same, yeah, from this formulation, general formulation, yeah. Okay. EA is equal to phase voltage minus JXS IA. Yeah, action in here is a symbol for the change load to be 30 horsepower, yeah. Now, so IA is equal to phase voltage minus EA action over JXS. So the last we obtain lah the value of IA is 41.2 angle 15 degree amperes, ya, yeah? This one, ya. Yeah? Now, so we can draw, ya, yeah, we can draw the phasor diagram. Ya, tengok ya. Yang ini tadi kan ini this phasor the vector of the phase voltage is as reference, ya, 200x. Yang ini tetap, ya, 200x angle 0 degree. Kita lihat yang, please look at for the EA 255 angle minus 12 volt. Ini kan yang tadi yang for the 15 horsepower. Yang ini ya, yang ini Factor ini yang tadi ya, yang for the 15 horsepower. Kemudian yang ini JXS IA is also for the condition of the 15 horsepower. And then you want to sketch for the 13 horsepower. Yeah, now so when you have to the uh, value of EA, yeah, EA for the 30 horsepower, the EA is equal to 250 angle minus 23 degree volt. So you can draw minus 23. Yeah, you can draw lah. It's around like this one. Yeah, this one. Ya, nah so you can inilah kalau kalau nak gunanya apa namanya tuh yang ini? Saya kok lupa. Yang nak buat circle. Jadi maknanya it is the initial point and here to here is S radius. Radius dekat sini kan juga sama tetap ya. Tetap 250 wide, but the angle is different. Ya, for the EA action is angle minus 23 degree. Nah, so after ini just draw the JXSIA like this one ya. Ini ya, like this one. Nah, ini yang ini. Nah, inilah JXSIA action. Kian ya. Nah, tadi kalau IA action 41.2 angle 15 degree ya daripada yang ini ya just draw the angle 15 degree and draw this line ya. IA action is 41.2 amperes. Okay? Okay, and then the last, what is the new power factor? Okay, new power factor can be obtained from this angle IA. Ya. Remember ya, power factor is always for the IA. Ya, mana saya indicate to the IA armature current. Now, so the armature current has the angle 15 degree. Now, so cosinus 15 degree. Yeah, meaning the power factor cosinus 15 degree is equal to 0.966, and then because the angle 15 has positive sign, meaning leading ya, this one ya. Okay. Now, so if you want to find the line current, because it is the line current for the 30 horsepower. Okay. Now, so IA is obtained 41.2 angle 15 degree. Now, so IA is equal to IL multiply IA is equal to IL over sub 3, or ya IL is equal to sub 3 multiply IA. Yeah, this one. Now, so we obtain line current for the load of 30 horsepower is 71.4 15 degree amperes. Nah, inilah ya. Okay, now so remember ya, how to draw, how to sketch this phasor diagram when the load change. Ya, when the load change ya. Oke, ada beberapa soalan untuk yang ini? Ada beberapa soalan? Ada
No,
beberapa soalan?
Dokter, no.
No juga Nurul. Oke, kalau no, coba tengok. If look at, ya dari phasor diagram ini saja ya, lagi senang. Ya, I think it is easy to show lah. When the load motor load change, yeah, from the 15 horsepower to be 30 horsepower, what can analyze from this condition? I means, yeah, please look at the value of EA, yeah, value of IA, yeah, the cos theta also power. Yeah, we can discuss lah. How about the power factor? Yeah, nah, so for example lah, for power factor, yeah, before 0.8 to be 0.966. It is better or not compare before in terms of the power factor? Huh? Meaning power factor close to 1 is better or not? Huh? For example, Nurafiza, Khor, Nuralina, Ahmad Akib, Aiman, Rignas, Sharifah, Fitri. Hah? Ya kan power factor is close to 1 kan is better ya. Nah, mana saya nih ya, nanti kalau ada soalan analyze, ya discuss lah apa yang boleh discuss ya. Paham? Hello. Paham ya,
Paham,
Cik ya?
sir.
Oke. So ini 25 mark ya, 25 marks for the test one. Oke, kalau tak ada persoalan, next example 5.2. Ya, ini pun sama saya ambil daripada buku Stephen J. Chapman. Oke, mana-manalah nanti you can see the book or you can see this lecture note. Please understand. Okay, example 5.2. Yeah, 5.1. Example 5.1 is for the load chain. Yeah, example 5.1 is for the horsepower chain. Yeah, and then I repeat again, when the load chain, when the horsepower chain, the internal generated voltage EA remains constant, yeah, but the angle delta, yeah, will change. Yeah, for the example 5.2, this one load remain constant. Yeah, how many horsepower is constant, but the flux change. Yeah, this example 5.2, we want to know the effects. Yeah, we want to know the effects of flux change for the behavior of synchronous motor. Yeah, example 5.1, yeah, for the effect of load change, for the effect of horsepower change, yeah, on the behavior of synchronous motor. Yeah, understand yeah, for this condition. Now, so example 0.2, yeah, for the effect of flux change, yeah, flux change. Okay, 208 volt, 45 horsepower, 8.8 power factor leadings, delta connected 60 Hz synchronous motor of the previous example. Dia motor data motor tadi sama ya, masih sama dengan example 5.2, 5.1. The yeah, supply condition for the power uh, horsepower 15 horsepower with an initial power factor 0.85 power factor lagging. The field current at the condition is 4 amperes. Yeah, A, find W of IA, EA, and sketch the initial phase diagram of this motor. B, if the motor flux increase, ini ya, if the motor flux increase by 25%, sketch the new phase diagram of the motor. What is the value of EA, IA, and power factor of the motor? Ya, motor sama, the type of the motor same, yeah, like example 5.1. But yeah, remember the synchronous motor on the rotor winding, yeah, is connected to the DC voltage source. Now, so for this condition, DC voltage source will be changed. The percentage to be 25%. Yeah, increase 25%. Yeah, it is the plug will be effect to the internal generated voltage. Ya. Tadi kan kalau yang tadi load change internal generated voltage remain constant. Tapi kalau flux change will be effect to the value of internal generated voltage. Keadaannya seperti ini sama-sama nanti kita we want to draw the phasor diagram. Okay? Okay, now so look at the power. Yeah, the motor is loaded by 15 horsepower. But for the power factor 0.85 lagging. Kalau tadi kan 15 horsepower, dia punya power factor 0.8 leading. Yang ini lagging ya. Yang ini lagging. Okay, now so Sam, yeah, 208 volt is as base voltage. Yeah, because delta connected, and then 208 volt is also line voltage. Yeah, output voltage 15 horsepower, and then cos theta power factor 0.8. Yeah, cos theta 0.85 lagging. Yeah, this one. Wheel current 4 amperes. Yeah, ini saya tulis ya. From the previous example 5.1, the input power including the power losses is given by, ya, kita dapatkanlah yang tadi kan sama ya. The input power is 13.69 kilowatt. Yeah, this one. Okay. Yeah, the question we want to find the value of IA. Okay, now so we can obtain the value of IA. Yeah, remember ya. If we write the phase voltage, phase current, yeah, for the total power, yeah. Now, so the total power for the three phase, yeah, for the delta, yeah, 3 multiply phase voltage I phase cos theta. Ini tadi saya rasakan ada saya dirap juga ya, yang dekat sini ini. Ah ini ya, ah ini. Ini ya, kalau kita dirap inilah, this one ya. Ini kan kalau I mana tadi? I paste. Ah ini nih. Ini PPS I paste cos theta. If the three paste kan multiply 3. Nah, this one ya, multiply 3 here. If you want to use the total power, yeah. Now so we can write like this one. We can write like this one. This one, yeah. So input power is equal to 3 multiply phase voltage, phase current cos theta. Yeah, phase current here, armature current. So we obtain the value of IA is equal to input power over 3 phase voltage multiply cos theta. Yeah, input power is 13,690 watt over, yeah, 3 multiplied 208, yeah, 208 is terminal voltage or phase voltage of the synchronous motor, yeah, 208 multiply cos theta. Cos theta is 0.85, yeah, this one. Yeah, now so we have the value of armature current is 25.8 ampere. Now so if you want to write this armature current in the phasor form, now so you can write like this one lah. Yeah, remember, yeah, this one is 0.8 lagging. Yeah, so we want to find value of this angle. Yeah, so this angle is equal to cosinus inversely 0.85. Now, so we obtain the 31.8 degree. And then remember, yeah, this power factor is mentioned as lagging. Now, so meaning this angle is negative, yeah. Now, so we obtain the value of armature current if it is written in the phasor form is 25.8 angle minus 31.8 degree amperes, yeah, because it is lagging. The sign here, negative sign, because lagging. Okay. Now, why we want to find the value of IA? Because we want to find the value of EA. Yeah, EA here. Yeah. Now, so EA can be obtained from this formulation. Yeah. EA is equal to phase voltage minus JXS IA. Now, phase voltage is 28 angle 0 degree minus XS 2.5 and IA from here. Yeah? Now, so last we obtain the value of EA internal generated voltage is equal to 182 angle minus 17.5 degree volt. Here this one. Nah, so we can draw ya. Ini coba tengok yang untuk awal yang mula-mula ya. For this for the ini kan ada this one is ada two type of the phasor diagram. Ya before change of the flux and after change of the flux ya. Ini I write here saya timpakan lah saya lukis. Okay, nah so we can start sketch for the phase voltage. This one. Okay, phase voltage is equal to 208 angle 0 degree. After that, you can sketch the vector EA 188, 182 angle minus 70.5 degree. The first you have to draw this angle minus 17.5. Yeah, it's around like this one lah. Yeah, 17.5 degree. Nah, ini following the scale, ya this one lah, EA. Yang ini ya. Yang ini. Nih, ya, yang ini. Yang EA 188, 182 angle minus 17.5 volt. After that, you can sketch the vector JXSIA. Yang ini. Just draw saja ya. Just drag from this end of EA to this end of the vector phase voltage ya. Ya ini ya. Nah, IA ya IA dia 25 angle minus 31.8 minus 31 ya minus 31.8 here. So IA here ya 25.8 angle minus 31.8 degree. Yang ini ya, dah ya. Yang ini. Yang satu lagi after ya ini kan ada dua the type of the EA. Yang EA ini nanti untuk for the flux change. Ya, B we can see. Yeah, the flux change or increase 25%. Yeah, remember when the flux change 25% means the internal generated follow will be increased 25% also. Yeah. Now, so if the flux is increased 25%, yeah, please follow this formulation lah. EA is equal to K flux omega, and from here we know that the EA is proportional to the flux. Increased flux will be increase the value of EA. Now, so EA is equal to 1.25 because 100% plus 20%. Now, so the total 125% or 1.25 multiply EA, the initial EA. Initial EA is 182 ya, 182. So 1.25 multiply 182 is equal to 227.5. Now we can see from here, if we compare, yeah, before this the EA is 182. When the flux increase, yeah, to be 227.5. Meaning we can see from here is proportional, yeah, flux and EA. Yeah, EA accent when the flux increase 20%, yeah, EA accent is higher than the first EA. Okay. Okay. Now so how about the power? Yeah. How about the power? Yeah. For this condition, I repeat again. When the flux change, the internal generated will change, but the power remain constant. Yeah, remain constant. Now so following this formulation, yeah, formulation same like formulation before, yeah, when we find the angle of delta, yeah, here, yeah, power remain constant, yeah, remain constant. Now, so meaning power before and after increase 20% of the plugs, yeah, is constant. So following this formulation, yeah, yeah, P is equal to 3 phase voltage EA sinus delta over XS. Yeah. Now, so means if we write, yeah, 3 phase voltage IA, phase voltage is remain constant also, yeah. XS remain constant also. EA is equal to, I write again, 3 V phase EA sin theta over XS is equal to 3 P phase EA action, ya, sinus delta action, ya, over XS. Nah, so kalau kita, saya pun tak pandai menuliskan sini. Ini boleh cut lah phase voltage 3 and XS. Nanti tulis sendiri ya. Nah, so the last we obtain the formulation like this one. Ya, EA sinus delta is equal to EA action sinus delta action. Nah, so we want to find the value of delta action here. Yeah, now so we can write like this one. Yeah, sin delta action is equal to EA sin delta over EA action. So if we substitute value of EA, yeah, EA is here to 182, and then EA action is 227.5 here, yeah, and then delta here for the delta here minus 17.5, yeah, this one minus 17.5 degree. Now, so last we obtain the value of delta action minus 13.9 degree. Yeah. After obtaining the value of delta action when the flux increase 25%, we can find the value of internal, the value of armature current. Yeah, when the flux increase also 25%. Yeah, yeah. Following this formulation, IA action is equal to phase voltage minus EA action over JXS. Yeah, phase voltage 200 angle 0 degree, EA action, yeah, obtained from here 227.5 for the angle minus 13.9. Yeah, this one over JXS, XS 2.5, J here is angle 90 degree. Last we obtain the value of IA action is 22.5 angle 13.2 amperes. Okay, last we can find the power factor. Yeah, power factor can refer from this value of IA for the angle. Yeah, cos theta is equal to power factor is equal to cos 13.2 is around 0.97 leading. Yeah, why leading? Because the sign of this angle is positive. Yeah, now so meaning leading. Yeah, now so the all data can be drawn for the phasor diagram. Yeah, like this one. Okay, same phase voltage is as reference, and then we want to draw the value of EA action. Yeah, EA action from here we obtain the, which one is it? 227.5 angle minus 13. So you can draw is around minus 13 ini dia angle ini ya, yang ini. Oke, cara lukis dia yang ini ya dari sini kemari ya. This one is angle minus 13.9 degree. Nah, cara lukis dia kalau tadi if you want to draw the effect of the load change yang gunanya trajectory apa namanya? Yang untuk yang ini flux change ya, you just ini apa nama? Horizontal axis ya. Ini horizontal line. Ya daripada inisial EA ya buatlah nih garis macam ini. Okay, after that you obtain 13 minus 13.9 degree here, how many, and then you can you can draw, you can sketch the vector of EA action. Just draw. Sini tarik aja line one line until arriving the line here. Ya itulah dia ya. Cara dia ya. After that you can draw the JXS IA here like this one. And the IA action like this one lah. The angle is 13.2. And then you can draw the vector IA action. Ya. Nah inilah dia ya. Now for this one same. What can you analyze? The effect of the the change of flux. Yeah. How about the EA value of EA? Yeah, value of the power, value of the cos theta, value of power factor. Oke, ada apa-apa soalan?